7.8 homework. So we're going to rewrite the numbers in scientific notation. Okay. So scientific notation, generally speaking, looks something like, well, let's just dive in and do an example. So scientific notation, first of all, you're going to have the decimal behind the first non-zero digit number. So in this case, we need to put it behind the 2. So far we end up with a 2. So it's 2 times 10 to some power. Okay? And the power it is going to be the number of places you had to move the decimal place. Now, if the original number was smaller than 1, it's going to be a negative exponent. If the original number was bigger than 1, it's going to be a positive exponent. So in this case, 0.02 is a small number, smaller than 1. And we had to move it 2 places, so it's going to be a negative 2 exponent. And the general forms of this is something like a times 10 to the nth power, or something like that, right? So the next one, it looks like we have 0.00006. So we have to move the decimal place over 4 places. And the answer is going to be 6 times 10 to, and we had to move this place over 4 places. And the original number was a small number, being smaller than 1. So it's going to be a negative 4 exponent. All right, so we have a number over here. We want to put the decimal behind the first non-zero digit. In this case, it's going to be the 5, which is way over there in the front, so we have to move the decimal from behind. There's an understood or implied decimal right there. We're going to move it over 1, 2, 3, 4, 5, 6 places. And so we end up with 5.77 times 10. And we count the number of places. Again, it was 1, 2, 3, 4, 5, 6. Except now the original number is much larger than 1, so it's going to be a positive 6 exponent. Over here, we have 0.0358. We want to move this decimal behind the first non-zero digit. Move it over 1, move it over 2. First non-zero digit was the 3, so we end up with 3.58 times 10. And because we had to move it over 2 places, we're going to have a 2 exponent. But because the original number was smaller than 1, it's going to be a negative 2 exponent. So Young's modulus for the elasticity of steel is 29,100,000 pounds per square inch. Rewrite 29,100,000 pounds per square inch in scientific notation. Okay, so the first non-zero digit, going from left to right, the same direction you read English, is going to be behind the 2. So we're going to move the decimal behind this last 0 here. We're going to move it over 1, 2, 3, 4, 5, 6, 7 places. So we end up with a 2.9 times 10. And we had to move it over 7 places. And 29,100,000 is much larger than 1. It's a large number. So that 1, 2, 3, 4, 5, 6, 7 is going to be a positive 7. So we can rewrite it as 2.9 times 10 to the 7th power, and that's an equivalent. Then we try the next one. It's 91 million watts. Rewrite this number in scientific notation. All right, so the first non-zero digit number that you see from left to right is after the 9, right? So right after the first non-zero digit number from left to right, after the 9. And we'd have to move this decimal behind the last 0 over 1, 2, 3, 4, 5, 6, 7 places. So we'd end up with 9.1 times 10 to the, and 91 million is much larger than 1, so it's going to be a positive 7. Next, we want to be able to convert from scientific notation into regular decimal form. So we start with a 3 times 10 to the 7th power. Now, because this is a positive exponent, we're going to want this 3 to become bigger. And we do that by moving that decimal over to the right. So we're going to move it 1, 2, 3, 4, 5, 6, 7 places. And we're going to fill in all those spaces with zeros. All right, so we end up 7 zeros there. So we end up with 3, 0, 0, 0, 0, 0, 0, 0. And that means we end up with 30 million. Okay, over here, we start up with a 2. 2 times 10 to the negative 5th power. So a 2 with the decimal behind it. But because it has a negative exponent, we're going to want it to look smaller. We do that by moving it to the left. 1, 2, 3, 4, 5. All right, so we end up with a 0 there, a 0 there, a 0 there, and a 0 there. And I always like to put a 0 in the first place just for clarity, but it's not necessary. We end up with 0.00002. Okay, let's try the next one. So we're going to write this number without exponents. So we start off with 5.4 times 10 to the negative 6th power. But because the exponent is a negative, we're going to want this to look smaller, so we do that by moving it to the left 1, 2, 3, 4, 5, 6 places. And I fill in the places with 0, 0, 0, 0, 0, 0, 0. Okay, so we end up with 0.1, 2, 3, 4, 5 zeros and a 4 and 5 and a 4. So double check. Okay, that works out. Okay, try the next one. We're going to rewrite 5.3 times 10 to the 8th power in decimal form. So because it has a positive exponent, we're going to want the number to look bigger, so we have to move the decimal over to the right 1, 2, 3, 4, 5, 6, 7, 8 places. And we'll fill in all of the places that we moved it with zeros. So we end up with 5, 3, 0, 0, 0, 0, 0, 0, 0. So we end up with 530 million. Okay, one more. We end up with rewrite the following in scientific notation and calculate the answer in scientific notation. If necessary, convert your answer to scientific notation. Alrighty then. Alright, so we're going to convert everything to scientific notation. First one, the first non-zero digit number is behind this 2, so we have to move it over 1, 2, 3, 4 places. So we end up with 2 times 10 to the 4th power. The next one is 200,000, so it has a decimal after the last 0, and we want to end up with after the 2, so we have to move it over 1, 2, 3, 4, 5 places. So that ends up being 2 times 10 to the 1, 2, 3, 4, 5th power. Okay, so now we rewrote the following in scientific notation, and we're going to calculate. Now, because we can pull these to the front, right? The 2 and the 2 are going to be multiplied together, giving us a 4. And the 10 to the 4th times 10 to the 5th, we're going to use the product rule. Because 10 to the 4th times 10 to the 5th, they both have the same base, so we add the exponents together, which gives us, right, so times 10 to the 4 plus 5, or 9. 4 times 10 to the 9th, that is in scientific notation. So we want to rewrite the following in scientific notation and calculate the answer in scientific notation if necessary. Okay, so let's convert everything to scientific notation. The first place is we're going to get everything behind the 2, get that decimal behind the 2, so it starts off behind this last 0. We're going to move it over 1, 2, 3, 4, 5 places. We end up with 4.2 times 10, and we moved over 1, 2, 3, 4, 5 places, and it was bigger than 1, so that's a positive 5. Big numbers, positive exponent. Okay, we're going to multiply this one, so we end up with we want to move this decimal behind the first non-zero digit, which is 1, so we're going to move it over 1, 2, 3 places to the right, so we end up with 1.9 times 10, but because we had to move it over 1, 2, 3 places, and the number was smaller than 1, that's going to be a negative 3 exponent. Okay, so now we're going to deal with these little numbers. So we have a 4.2 times 1.9 times 10.5 times 10 to the negative 3rd. Okay, so we're going to have to use a calculator on this. We get 7.98, so 7.98. And we have 10 to the 5th multiplied by 10 to the negative 3rd, so we add those together. 5 plus negative 3 is a positive 10. So it's going to be times 10 to the, 5 plus negative 3 is going to be a positive 2, so we end up with a positive 2 there. So next we're going to have this one. I'm going to convert everything first to scientific notation. So the first non-zero digit from left to right, 0, 0, 0, 0, 0, 0, 8. So we're going to put it behind the 8. So we're going to move it over 1, 2, 3, 4, 5, 6 places. So that simply turns into 8.8 times 10 to the, and we had to move it over 1, 2, 3, 4, 5, 6 places, but it was a smaller than 1. It was a small number, smaller than 1. So we have a negative 6 exponent. And now we have to convert this one to a scientific notation. First non-zero digit number from left to right is a 3. We have to move the decimal over 1, 2, 3 places. So we end up with 3.8 times 10 to the 1, 2, 3, 3. And since the number was larger than 1, it was our large number, we're going to add a positive 3 exponent. So now we have 8.8. And I can rewrite this as a fraction. Maybe this will make more sense. So we have 8.8 times 10 to the negative 6 power divided by 3.8 times 10 to the positive 3 exponent. Okay, so we're going to need a calculator for the first part. So we end up with 2.316 about. It just keeps going on forever. 2.316. And then we're going to use the exponent rules on this. So 10 to the negative 6 divided by the 3 here. Negative 6 minus 3 is negative 9. So 10 to the negative 9th power. Okay, so let's move on to the next one. So right here we're going to convert 76,800 to a scientific notation. So we're going to turn this to 7.68 times 10. And because we had to move it over 1, 2, 3, 4 places, and that was a larger number, so it's going to have a positive 4. Over here we're going to move this over 1, 2, 3 places to get it behind the 9. So that will give us 9.6 times 10. And we had 1, 2, 3 places to move it over, so it's going to be a negative 3 because the original number was small. So now we're going to divide, right? So we put 7.68 times 10 to the 4th power over 9.6 times 10 to the negative 3rd power. We have to get a calculator to figure out what that is. 0.8, which gives you 0.8 times 10 to the, so we had a 4 on top minus negative 3. Now if you have 4 minus negative 3, 4 minus negative 3, that's the same as 4 plus 3, which gives you 7, so to the 7. Now there's a problem here though. It's not scientific notation because we don't have that decimal behind the first non-zero digit number, so we have to move that over 1, right? And that is a 8 times 10 to the negative 1 power, right? So this whole entire 0.8 is equivalent to 8 times 10 to the negative 1, and we still have 10 to the positive 7. Well, we have to subtract 1 from that 7. Now there's a trick to this. If you already know it, go ahead. But if it's a smaller number, you have to decrease that exponent by 1 to take advantage of that, or to take into account that one space that you had to move it to get rid of. But this is how it looks algebraically, right? Negative 1 and a positive 7 gives you 8 times 10 to the 6th power. So we're going to do something